functions are arguably the most important aspect of any programming language, allowing you to break down the flow of your code into reusable chunks. Understanding what can be done with function syntax is integral to writing clean and functional code. Okay, so let's take a look at the syntax for writing a function. Now, here we've defined an example function using fn example function, soft brackets and curly brackets as well. Now, it's sort of similar to C++ in that you'll have the function name and then soft brackets for parameters, curly brackets for function logic, except we have this here, which is a little bit different, the fn. Now, that's just the keyword for defining a function in Rust. So, and once we've defined the function, we can put the logic inside. So we could write something like, to go in here, could write print hello or something like this. Now in just pseudocode, that's not the exact syntax for Rust print. And you can do all sorts of other things like storing values, returning values, and completing other actions such as incrementing values or creating data structures inside functions. So it becomes obvious very fast how helpful functions will be for making our code more modular and versatile. Now let's see what we can do with actions and storing values in functions. And okay, so here we have two functions, one hello world, that's just going to be an action, and one function with return, meaning we are going to define a variable and return it. So with hello world and with the other function, we see this little pub word before fn for defining a function. Now, this is okay. Now, what pub does is basically makes the function accessible from any scope within the script. So if you define a function in global scope or within a module, pub will basically tell Rust that you can access hello world from any other function. So we'd be able to call the function hello world within another function. Like for example, we could like stick it in right here if we really wanted to, or some other function that we decide to define later in the script. So with these functions, we can either call an action, in this case, print hello world, or we can store a value and then access that value if we, let's say, store the call to function with return in a variable like this. Like if we said let y equal to, just to abbreviate, function with return, and then brackets with some random number, 3. So this would mean y is equal to 5. And that is because we're returning the value in this function. Now, unlike other languages, we don't necessarily need to have a return here. In fact, that would throw an error. We just say the variable at the end that we will be returning out of the function, just like x. And unlike the function with return, in our hello world function, if we were to say let x equal hello world, this would not store any value. All this would do is execute the action. Now, just because we're storing the call to hello world in a variable doesn't mean that the action won't happen. It's not like that's only being stored in the variable x, unless we call like x or something, and nothing's going to happen. It's still going to print hello world to the console so that we won't run into any problems. And from this sort of perspective, the function hello world is only one line. So we just have this print statement. And even the function with return, we are just letting x equal to some variable input plus 2 and then returning x. So it doesn't seem the use of 2 lines to define the function is sort of worth it at all. For just the one print, we can just call print any amount of times and we won't really save any lines. But imagine if we had a function with some parameters. Let's say we had pub function math, and we do some sort of expression, like we have x, y, and then curly brackets. And what we do inside the function is some mathematical formula that has multiple lines. So we say x on some operation with y, and then we need to say define a new variable, like let c equal some combination of x and y, and then like use z between x and y somehow, and then return the result. So if we changed x, then just like return x or something. Now, this is multiple lines that we can use over and over again, given 2 inputs. So we could save 4 lines of code in this case, or 3 lines technically, every time we call the math function with the 2 parameters, because all we would need to do is this, and that would execute everything that's inside the function. So it becomes obvious very fast how helpful these functions are going to be for developing skills with Rust. And so, with that in mind, I'd like to take a look at some of the other syntax tricks with functions in Rust and how we're going to use let expressions and curly brackets within functions to do some cooler things. So let's see what we have here in our main.rs file. We're going to see some things that we've seen before and a little bit of a different syntax style, as we can see here, and also here when we are just adding 1 to x. So with the hello world, nothing different. We are just println hello world, so that'll print hello world to the console. With +1, we are just returning x plus 1. Now, I should mention that this is a little bit different than what we've seen before. Is in Rust, we said previously when defining data types with variables, at least, that it's not necessary to specify that, let's say, x is a signed 32-bit integer, and then this arrow thing as well. Like, it looks a little weird, but it is necessary in functions. Now, the reason has to do with the compiler in Rust. So generally, when you don't define a data type, Rust figures it out for you, right? But in functions, what Rust decided to do was make defining data types required. And this is so that anywhere else in the script, when a function is called or reference or a variable is used within a function, the compiler has to do no effort to figure out what data type is either going into the function or being used. It can check back at the function definition, say, oh, I know that x is going to be an integer, so I know that x is going to be an i32 integer, so I don't need to put any other effort to figure out what the data type of x actually is, which is super helpful for speed, just a little bit inconvenient to us because this syntax is definitely weird. And down here, we see some very weird syntax. You see the curly brace as well, which is not something to expect after variables, especially when considering syntax in other languages. But it's kind of similar to a function here. And we also see this x plus 1 without a sort of colon or semicolon at the end, signifying a return. But you don't normally return things from variables, which is why it's weird. But the way we can think of this, if you define a variable and there's curly brackets after that definition, then you can sort of think of it as a function. So the equal sign signifies like a function that returns a value instead of a function that does an action. So when you set y equal to this curly bracket block of code, you can expect a value to be returned, and then that value within these curly brackets will be assigned to y. Now, if we said something like, oh, x plus 1 colon, like you would expect to do in other languages, then this would throw an error because it'll expect something different from the compiler. So let y equal to any block of code within the curly brackets will expect a return, and that return value will be assigned to y, and then we can access it with y. So let's see what happens when we run our main script here. From what we can expect, we see that y is equal to 5 plus 1, so that's 6. So when we say the value of y plus 1 is, we're going to expect 7, hopefully, and then we'll also get this hello world, and this is the syntax for calling functions as well. You just say the function name with soft brackets and then throw in the parameter. So let's see what we get here. So the compile was successful, and we see hello world, and also the value of y plus 1 is 7 as expected. And so that covers the basic syntax of functions. Next video, we will learn how to do loops and conditionals, but definitely get a amazing hold on functions before moving on to that. Great job and happy coding.